Okay, so we are going to be working to understand inverses when we're looking at log and exponential functions. So we are working out of 5H from the Unit 3 and 4 methods textbook. Um, so as we just need to think about inverse is that there is a imaginary line going at y equals x. So here we're able to see that line. And what we notice is our x value and y values are switching. So that's really all we are doing. Oops. So that means if I get this laser point, when I've got x is 1, y is 0, that switches to when x is 0, y is 1. So we can see that relationship it's got the same distance away from this line. So the first thing we need to be thinking about is when we are finding the inverse of the function and stating the domain and range. The first thing we need to be thinking about is if we are switching y and our y and x value, then the domain is going to turn into our range for our inverse. So in function notation, the domain of our function is all real numbers, which means that is going to be our range of our inverse. Likewise, we're thinking about our range of f. That's going to turn into our domain of our inverse. So the range in this function here, it's got a vertical shift up by 1, which means that the range here is going to be 1 to infinity and it will never equal 1. So when we are uh, when we are creating our function, the first thing we need to be thinking about is just plugging in x and y and switching them around. Now we just need to get y to be the subject. So the first thing I do is take away 1 on both sides. And after that, I use the relationship that I have with log. Now we know log base e is, we can write it as ln and we'll get y by itself. So it'll be y is equal to ln in brackets x minus 1. If I wanted to write it with the inverse, I'm going to say f to the power of negative 1 is equal to ln x minus 1. Okay, so for this next function, we've got the function has a domain of negative 1 to infinity. It is for all real numbers on the graph. F of x is equal to 5 ln 2x plus 2. So the first thing I want to think about is what is my domain? Well, we can see it right here, and we know our domain of our function will be the range of our inverse. So I can keep it as negative 1 to infinity. The second, I need to look at the range of this current function, and the range is going to be all real numbers. So I'll just put an R. So now I need to use this relationship to help me out to go back the opposite way. So we're just going to rewrite 5 ln 2x plus 2, but instead of putting x here, we'll put y, and instead of y over here, we'll put x. Now, the first thing I'm going to do is get this 5 to the other side, so I'll divide both sides by 5, and now I'm going to use my log understanding. So remember, ln is a log base e. So that will turn into base e x to the power of 5, my exponent, is equal to 2y plus 2. Now I just need to get y by itself, so I take away 2 from both sides and then I divide everything by 2. So that gives me y is equal to a half e to the power of x over 5 minus 1, and I'll write it with the inverse notation. So let's look at the next question. Find the inverse of the function and state the domain and range. So again, I'm going to do exactly what I've just done before. So just ignore that part. I just realized that we had just done that question. So we're going to move on to make the pronumeral in brackets the subject. So we've got q is equal to be to the power of negative 4x, and we're wanting to get x, the subject. So straight away, I'm just going to divide both sides by b. That gives me q over b is equal to e to the power of negative 4x. And now I'm going to use my log understanding. So that means this can turn into log base e. Q over b is equal to negative 4x. But because we know it's log base e, I can just write it as ln. Straight away, I'll get my x by itself. I'm just going to divide everything by negative 4. So I'm going to get negative 4 over ln qb. Likewise with the next question, y is equal to 6 in brackets 1 minus e to the power of negative 2x. I would like to get x by itself, so I will just divide everything by 6. To get rid of this bracket, I'm going to get rid of this 1, so I will take 1 away. Now I want to get rid of this negative, which means everything on this side will change sign. So this y over 6 will be a negative, and this will turn into positive. Now I can use my understanding of log. So this is going to turn into ln, or you could write log base e. Both are still correct, but we're going to write it as ln. So ln negative y over 6 plus 1 is equal to negative 2x. And then finally, I'm just going to divide everything by negative 2. So I just put the negative on top and I divided this by 2. Okay, when we're finding a coordinate of points of intersection of the graph y equals f of x and the inverse, the first thing we need to be thinking about is when we've got inverse, there is that imaginary line. So that imaginary line, and I've just put the two graphs, will go straight through the middle. So that because the x and y values will switch, it means that at that one point, that is where that they are going to be joined because it's like a mirror. So the intercepts will always be on that line. That means we don't need to find the inverse to find where the inverse will intersect. All we need to do is use simultaneous equations. So we know y is equal to x. So wherever y is in my original equation, I'm just going to put x. Now I can solve it. So I've got x is equal to 3e to the power of x minus 5. I've got x plus 5 is equal to 3e to the power of x. And then I divide everything by 3. Now, we can't go any further than this without using the class pad. So all I'm going to get you to do is type this in and solve it on your class pad. And you should get two answers. X is equal to 0.629 and x is equal to negative 4.979. Now, at this point, when this is x, that's y, so we can put it straight away into a coordinate. If you want to double check, you can substitute them into the equation and then solve, and you'll get exactly the same. So be mindful of that.